Hello, everyone. Thank you all for coming. My name is Alex Gonzalez. I'm coming from Cloudera. I'm based at Austin, Texas. I've been a software engineer, a security software engineer for the last 5 years. I specialize in data encryption and key management. Lately, I've been involved in talks in relation to authorization, authentication, and auditing. So the talk of today, or the next 247 slides, we're going to be talking about the future of Hadoop security and its evolution. Do you know how much a security breach could cost? According to statistics, it can cost up to $355 per single record stolen. That's very expensive, and the users and customers are really worried about this. Over 70% of the organizations that had been compromised or been attacked had reported that they have reported a successful cyber attack on them. There is also another kind of consequences that a security breach might have, and these are steep fines. You know that GDPR is coming soon next year here in the European Union, and the customers are really worried that they need to comply with those regulations in order to avoid costs on them. As well, there might be loss of jobs if there is a security breach because the CEOs might lose their jobs. One example is Target a few years ago with Beth Jacob, and as well recently, you probably know that there is a company in the United States called Equifax, and there was a security breach, and the CEO as well had to step down from there. Another security breach consequence is that the users might lose customers, and that's really not desired. That's going to have a direct impact in the business. So in a survey to 2,900 companies, 20% of them reported losing some of their customers when they had a security breach. Security matters. What Hadoop users want to do? Well, they want to protect the data, they want to be in compliance, they want to anonymize the data, and they want to move to the cloud. The reason of moving the data to the cloud is that there is cheaper infrastructure, and there is a new tendency to use transient clusters instead of having a cluster that is going to be running all the time. That will be way more expensive. So in the case of migration to the cloud, you just store your data in S3, for example, or a data lake, and then you launch a cluster whenever you need to do data processing without having all the clusters being charged per hour as Amazon does and any other cloud. What the community has done so far in terms of security? Well, there have been multiple efforts to make security stronger in Hadoop. But the problem is that there have been a lot of efforts, and those are not they are not thinking in integration as one of the main components. We're trying to do some things in the encryption at rest or auditing or TLS or authentication authorization here and there for HDFS, Flume, UCI, Zookeeper, Hue, blah, 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 blah. Security is finally very, very confusing. What the community wants to do? Well, we want to secure all the data by default. We want to lock all the data and just give access to certain users to the data that they need to. The people from accountant department, they don't need to have access to the marketing department. That's a different set of data. Also, we want to be regulatory in compliance all over the world. There are many regulations all over the world, and that's what the community is looking into as well. And finally, we need to ship vulnerability-free software. So for example, I was mentioning before that Equifax recently had a security breach. The problem was that they were using a third-party library, and that had a security breach. Well, they had a hole pretty much. So that's how they got their data stolen. So what we need to do is to avoid bugs and security holes in the code, of course. As an example, and this is a very interesting use case, there is a financial institution in a country that I cannot mention, and the government of this country will not allow this company to move the data to the cloud if they will not own their encryption keys. Basically, as anyone knows, whenever you have the keys of your house or your car or so, you need to keep the keys on your pocket. You need to be the owner of the keys. You cannot rely on someone else to keep the keys for you. So pretty much the government said the same. Azure, Amazon, they have key management solutions. And those solutions are, or the way that those are implemented is in a way where Amazon and Azure, they store the keys for you. And the companies don't want that. They want to own the keys themselves. So there is, in Cloudera, there is an innovative key management solution called KeyTrustee. And with that one, you can launch a host, you launch a server that is going to store the keys, but those are going to be your keys because it's your host, might be in the cloud, but you're going to have ownership of the management and of the data of the keys. So in that way, the government allowed this company to move the data to the cloud, or this bank. So if you go to Apache Hadoop, you're going to find that the main topics that we're talking about are authentication, data confidentiality, and configuration. But there are other, or pretty much we can resume all this in 4 different dimensions. One of them is we want to protect the perimeter. Basically, we want to provide authentication mechanisms, such as technologies with Kerberos, LDAP, or OSAML, SSD, etc. We want to provide certain levels of authorization through Sentry and record service to provide or to limit the access to the data. One thing is authentication, second thing is authorization, right? And the third one is data. We want to do data masking on the data, so it's not readable. For example, if you have your credit card, you might see in some systems that you X the first part of the credit card and you just show the last 4 digits. That's data masking. As well, we have data encryption for HDFS encryption, for example, and we have key management through KMS as well. The last security dimension we have is visibility. We want to do, well, we can do audit, we can do data governance using, for example, Apache Atlas. So whenever there are use cases that Hadoop is not ready to comply with security, there are companies that are offering security solutions. And what they do is encryption at rest, they do key management as well, they do data governance, and they do in-transit encryption and data masking. So there is options. Now, what is next? What is the vision? What do we really want to go? What is needed in the community and what the users want to have? There are 4 topics where we are attacking the future of Hadoop security. One of them is scaling security administration, and that's done through ABAC, or attribute-based access control. I'm going to talk in detail about each of these. We want to have as well centralized identity management, and one of the options is single sign-on. I'm going to talk in detail about it as well, and federating multiple directories. We want to have common security across multiple clusters in the cloud. That means that we can share policies all over the cluster. And we want to have executive visibility through centralized security dashboards. Now, let me talk about ABAC. And this is probably one of the most interesting features that are coming in terms of security. So attribute-based access control, for example, is not role-based access control. Every object has an attribute. For example, this remote control, it's black, has a size, has a width, has different buttons with different colors. Those are its attributes. But another object might have similar characteristics for a different type of remote control, but that's going to be for the TV, for example. Those kind of attributes are the ones that we are going to be applying to different entities in the data. And different levels, for example, you can add attributes to a column, attributes to a table, attributes to a database, etc. As an example, ABAC, the users, like themselves, they can have attributes. What is the department that they belong to? What type of documents they usually have to access? Where is that region where the user is based at? So that those kind of attributes. And then you can have informational assets, the documents might be as well. What is the department that is related to that document? What is the content type of that document, etc. So in the terms of environment, we can establish what the session, when the session started, where the session started. For example, you can access the data or do a transaction in a bank only between 9 a.m. and 6 p.m., not beyond that, from a physical bank station. So you can restrict, based on attributes, the access of the transactions to the databases if they are coming from that entity, which is the physical bank. As well, you can also do filters through the IP. And for this, as soon as you have attributes in your entities, you can evaluate those attributes. And as soon as those are evaluated, you can allow or deny the access to a third entity to the data. And that's going to be done through conditions, right? Policies or rules. Well, the way that it's going to be done is through Sentry or record service, and it's going to be done through policies that is just a set of conditions that is going to say, for example, permit the users to access this document if they are coming from this department when the time is greater than this or lower than this, unless another condition. So the interesting part of ABAC is that you can mix attribute-based access control and role-based access control. So you are going to have complex policies. You might have the input, the output of one policy might be the input of a different policy, just like you do with SQL or so. So the benefits for ABAC is that you are going to have fewer security policies per object, and that means that is really, really interesting. So we have customers, Cloudera has customers that have some tables, and each table has 10,000 columns. That's a lot of data, and they have like 50 tables, right? So we're talking about petabytes of data. So right now, they are doing the filtering and the authorization through role-based access control. That means that if you have 10,000 columns, you need 10,000 rules, 10,000 policies. That's a lot of work for the administrator, the data administrator. So if you tag, for example, the first 1,000 with one tag, all of them, you tag them with the sensitive information. Each of the columns of that table, you can create only one rule that is going to control all the tables through the attributes, right? And you can have one column having multiple attributes, so you can have different policies over that column. As well, you can tag the table and apply, instead of a set of columns, you can apply it to the set of tables or one single table. Another thing that is a benefit is that you can have central policies enforcing while still delegated administration. That means that for example, I am the main data administrator, and I put tags everywhere, and I put rules or policies everywhere. But then a second administrator comes, and I want to share him one table. I share the table, and he's going to have the attributes there and the policies in place. So the second administrator doesn't need to do all the rework of tagging things and creating rules, right? So that in that way, we can have central policies that are going to be distributed for everybody. And we're going to have better protection since more factors can be used. As I said, you can create complex policies, and that's going to help us to do finer-grained permissions. There are some banks in Canada that are already asking for this feature. There is also, as well, one large bank worldwide. And there are as well some customers that they had presented some use cases that they want to solve, and they don't know how to solve it. We know that with ABAC, we can provide a solution, but it's not yet implemented, and that's what we want to do, right? The community itself. Now, let me talk about a different initiative that we have. This is single sign-on. Single sign-on is probably, well, there is one technology called Okta where you just type one password and it stores all the passwords from different applications. But that's not a good example because probably not everyone knows about Okta, but I'm going to try to be clear with this one. So when you go to Hue or you go to HBase or Zookeeper or HDFS user interface. You need to type a user and password for each of them, which means that you have around 20 user interfaces, and you need to type a user and password for each one of them. That's not the best user experience, of course. So what the community is looking for is to create an authentication service where you are going to log in once. It's going to provide you one token, and that token is going to be enough to access to any other user interface without typing your user and password again. So the benefit of this, something as well is that authentication service is going to be an interface as well with Active Directory and maybe Kerberos itself. So the benefits is that improves security user experience. You don't need to manage or work with different user and passwords. Increases productivity as for the data administrator or the cluster administrator and the same users. Strengthens security. Recently, HBase had a problem, and the problem was that you can access the data through the user interface even without providing a user and password. That was really bad. So that's already fixed. And if we will have an authentication service, then that problem will never happen, right? Also, it improves auditing. You don't need to do auditing for 20 accounts per user. You just need to do one account, user and password per user, and reduces in the long term support costs for the customers and for the companies as well that have Hadoop distributions, and as well the engineering effort is reduced. The third one is called Centralized Security for the cloud. As you know, Amazon has EMR, Elastic MapReduce, and this is Hadoop as a service, right? So we want to have, or we want to provide services in the cloud, or kind of create the architecture to provide services in the cloud that are going to be centralized, that are going to have centralized security. As an example, we have this cluster of clusters where we have one main one in the center, and we have, for example, right now, 4 sentries, one in each cluster. Doesn't make sense. We have 4 KMSs and everything. So if we move sentry into the one in the middle, and we also move the KMS to the one in the middle, every single cluster around the central cluster, the centralized cluster, is going to use the same rules as sentry. It's going to use the same keys stored by the KMS, and it's going to use, for example, I'm putting as well HMS, the Hive Metastore, to comply with Sentry HA and Hive Metastore HA, right? That's kind of the general architecture that the community is looking for as well. So this is called shared data experience, and based on this kind of model, you can do data engineering, analytic database, you can do data science, and it can behave as an operational database. And it doesn't matter where you store your data, because the place where your data is going to be stored might be HDFS, or Kudu, or S3, or any private cloud storage. So the benefits are that it reduces the cost of ownership. There is less number of hosts, for example, increases end user productivity. You don't need to recreate the rules. All the rules that are in the centralized cluster are going to be shared across all the clusters. And something really interesting is that it's faster expansion, way faster expansions, because as soon as you launch a new cluster, you just attach it to the cluster that has all the security policies, and everything is going to be there, right? So you don't need to recreate anything, and it's going to be like security on the fly. There is one, it's worth to mention that there is one as well initiative that is related to AVAC and this kind of faster expansion. We want to secure the data as soon as it lands in the cluster. This means that you can create certain attributes to the columns of the data that is going to be in place. And so before the data lands, you have the table structure, for example. It already has some attributes. So the data is stored there, and nobody can access it because the rules are already in place before the data lands, right? So that's one of the approaches of looking at attribute-based access control as well. And the last one is that we want to have one centralized way to control everything. Right now, security is done through many, as you saw before, like I was just mentioning, these kind of components that have their own security pieces. Hue, HBase, everyone has its own security pieces everywhere. So we want to have one centralized endpoint or console where we can do centralized access control for ABAC, role-based access control as well, where we can control the encryption keys, where we can have data address encryption, so we can tell what data is encrypted, what data is not encrypted, and what data should be encrypted. As well, we can do some policies management for ABAC or role-based access control, and we want to have the certificates managed over there. So we can take action and tell the users, your certificate is going to expire soon. You need to take action. Or maybe the Hadoop or these new components might be smart enough in order to do the renewal of the certificate. And in this centralized security console, we can also have single sign-on management, right? We can create the users there, we can remove the users, we can update policies or so, and we can rotate or remove their user and password or management areas for single sign-on. The benefits is that, of course, it improves the user experience. Instead of going and typing everything on the CLI, you can have a friendly user interface where you can do everything from a browser. And you are going to have as well centralized management, only one console, only one place to go, and only one place to do all the security related. Would you like to have your personal data exposed? Thank you.